So the purpose of this video is to walk you through a couple of examples of how we can compute the sum of some finite geometric series. So I know I've mentioned in a previous lesson, but I figured I'd mention it again here. This is the formula for the sum of the first n terms of a geometric series. So you put in the first term of the series, you put in the common ratio, and you put in how many terms you're looking to add together, and this formula will give you what you're looking for. It'll give you the sum of those first n terms. So I have one really simple example, I think, and then one that's a word problem that's a bit more complicated, but I've seen it show up on past IB exams, so I want you to be prepared for it. So let's look at that first simple example. So here we go. Find the sum of the first 5 terms of the geometric series whose first term is 5 and fourth term is 40. So they want us to find the sum of the first 5 terms, right? That means we need to do the first term times 1 minus the common ratio to the 5th term over 1 minus the common ratio. So here we're in a position where we've got a formula, we've sort of plugged in the numbers, we know what the first term is, we know it's 5. The thing we seem to be missing is we seem to be missing r. And I know I've mentioned this to some of you in class, and I may not have gone over it in a previous video, but if you're missing a variable in a summation formula, it is very commonly the right thing to do is to go back to the sequence formula and figure it out. So I'm going to say that again in case you missed it. If you're working with a summation formula and you're missing a variable, very commonly what you're supposed to do is you're supposed to go back to your sequence formula, the one that said that the nth term was equal to the first term times the common ratio to the n minus 1 power. Often you go back to that formula to find something. And some people would say, oh, well, but I'm adding things. Don't I want to use the sum formula? Sure, but the thing that you're summing is a sequence. So understand, using the sequence formula is often a good idea. So the fourth term, u4, is supposed to be the first term, which is 5, times the common ratio to the 5 minus 1 power. I'm sorry, not 5 minus 1. This up here should be 4 minus 1, because it's the fourth term that we're looking at, right? So 40 is equal to 5r to the third power. That means r cubed is 8, which means r has to be 2. So now that we have that, we can put that back into our summation formula. The sum of the first 5 terms will be 5, that's the first term, times 1 minus 2 to the 5th, all over 1 minus the common ratio of 2. So the sum of the first 5 terms is 5 times negative 31 over negative 1. So sum of the first 5 terms will be, let's see here, looks like it's going to be 155. And there it is. Very straightforward. If you've got the things, you plug them into the formula and you're good. The more complicated example that we're going to look at here in a minute sort of sets up a word problem for you, and you're going to need to figure out what the first term is with the common ratio, how many terms. You're going to need to figure those things out. Most of the examples of these on the IB exam, I think, are going to be simpler ones like this one. But sometimes you'll see more complicated ones. So let's look at that next. Alright, so this example is a little complicated, but I have seen it on past IB exams, and so it's worth our time to look at and talk about and at least discuss how you can set it up. A problem like this, I think, will always be written in multiple parts like this, so you'll be at least able to get some of the first parts and maybe get some partial credit on the last part if you can't get the whole thing right. So the setup. A person decides to invest $100 on the first day of every year for 10 years. So, presumably they'll put in $100 on January 1st of 2013, and then another $100 in on January 1st of 2014, and then another $100 in on January 1st of 2015. They keep doing that for 10 years. The idea is that the money is invested in, some bank or whatever that gives you 5% interest that'll be compounded annually. Okay? So part A is how much is that initial $100 investment worth at the end of the 10 years, right? So for part A, you've got $100 that's getting 5% interest for 10 years. Since it's compounded annually, there's a formula that you need to remember from intermediate algebra, and that formula is that the amount that you have is equal to the principal amount times 1 plus the rate of interest raised to the time power. There was another version of the formula that had, that was r over n, and it was raised to the nt power. That's if it's compounded, and it's compounded n times per year. This one, it says you're compounding annually, so that's just going to be left as 1. So in this case, the amount that you'll have will be the principal, that's $100, times 1 plus the interest rate, that's 0.05, and it's raised to the time power, so it's raised to the 10th power. Right? If I plug all that into the calculator, I'll end up finding out that that initial $100 is going to be worth $162.89 after 10 years. Right? So you put that $100 and you leave it there, it is worth that amount. Okay? Now part B, you don't need to use a calculator for. Part B, they're simply asking you to write an expression for the value of the second $100 at the end of the 10-year period. Right, and I'd really like you to pause the video and think about this. I'd like you to think about, so that first $100 was put in there, and this is how much it was worth, right? This was the expression. When I put in the second $100, write out how much that's going to be worth at the end of the 10-year period. And the big hint there, and if you don't want the big hint, then pause fast. The big hint is, how long is the second $100 in the bank? Okay. So hopefully you recognize it's in there for 9 years. Right? If you invest this money for 10 years, the second $100 you put in is at the beginning of the second year. That means there's only 9 years left for the money to accumulate interest, right? So the amount that's going to be worth is $100, that's how much you invested, times 1 plus 0.05 raised to the 9th power. And this is the answer for part B. Okay, so the first $100 got to be invested for 10 years, the next $100 got to be invested for 9 years. Part C now asks, if the person continues this plan for 10 years, how much money will they have in the account at the end of the 10th year? And again, I don't know that I would expect you guys to sort of see how to do this without us talking through it, so that's why we're going through it here. I think the key to do this is to look at the pattern, right? How much was the first $100 worth? Well, from up above, it was 100 times 1.05 to the 10th power. How much was the second $100 worth? Well, it was invested for 1 year less, so it's 100 times 1.05 to the 9th. Okay. How much is the third $100 going to be worth? Well, the third $100 will be invested for 1 year less than that was, and so on. Right? I mean, we could sort of continue this process down. How much will the 10th $100 be worth? All right, when is the 10th $100 invested? It's invested right at the beginning of that 10th year, so how long does that $100 stay in the bank? That last $100 stays in the bank for 1 year. Right? So my thought on this thing is, we'll take a look at this thing. How many terms do you have here? We should have 10 terms. Do you recognize that this is geometric? Do you recognize that at each successive year you're multiplying by another 1.05? What I'm going to do is I'm going to consider this to be U1. Even though it was the last year, I'm going to consider this to be the first amount. And the idea is that each year that I go back, I have to multiply by a common ratio of 1.05. How many times do I do this? Well, there are 10 terms that we're working with. There are 10 years worth of money that are being collected. And so if I use the geometric series formula, I should be able to add this whole thing up. Right? We know from before that the sum of 10 terms will be U1 times 1 minus the common ratio to the 10th power all over 1 minus R. Right? Well, my first term we said was going to be this guy here, 100 times 1.05 times 1 minus the common ratio, that's 1.05 raised to the 10th power, and it's all over 1 minus 1.05. Right. Final thing you do is carefully plug that into your calculator, and if you throw it all into the calculator, you should find that the total amount of all these investments is $1,320.68. That may have been confusing. If it was, I really recommend you sort of go back and look at this again. Try and critically think through this. Yeah, I mean, it's like I said, it's a complicated example, but it has shown up on past IB exams, so I want you to at least be prepared for it and ready to answer it. That's the end of this video. That's all I have for examples of this. I hope that all the ones you guys see in the assignment will be straightforward enough for you to work through.